Welcome back to the shop and to the channel. I haven't had a whole lot of time this week to do some actual machining, but I've been putting together little snippets of some small projects I've been working on. Figured I would share those. Plus, I've got some new tools that I've acquired, a couple of which I think are pretty cool, pretty unique. You don't see very often. So stick around. I think you might like what I have to show you. But like I said, I've been doing some small projects here and there, and I want to just kind of share those. Not enough of a project to put in a video on its own, so here it is. I had mentioned in another video that I finally bought myself a decent 3D printer, and I've been putting it to use here in the shop, trying to do a little bit of tool organization. And this is what a lot of my drawers look like in the shop. It's just tooling just kind of laid in here, and I want to make this better. So I started with getting these R8 collets a little more organized. And what this is a system called Gridfinity. It's been around for a while. It's got these grids that are a standard size and distance apart, and it's just as easy to print these different kind of storage. Now these right here, I custom made these because there wasn't anybody that had something like this. I went ahead, and you can see on the bottom, I started with a template from a website. I'll try to remember to link it down below. That just built up a plain box, and then I got a 3D model of an R8 collet off of McMaster-Carr, and I inserted that into my model, and then just extruded the material around it. Made it just a little bit less than half of the overall size of it, and I think it's it's going to work out good. I really need to do more. I'd like to have one for this, but this space right here really isn't quite big enough to hold that, so it's just kind of set in here. But this takes a while to print all this, but it is, in my opinion, it is well worth it. Well, over here on the Bridgeport, if I try to turn this on without turning the rotary phase converter on, it won't power up, and that's a protection device, so that I don't accidentally try to turn on the machine when it only has the two legs of the 220 and when the rotary is not enabled. Inside this enclosure on the back of the Bridgeport is a phase monitoring relay, and it won't enable me to turn on this machine unless it sees all three phases from the rotary phase converter. And if it does, I can push this green button, and that triggers the contactor, which allows the power switch on the front of the machine to operate. Again, this is just a safety device so that I don't try to turn on the Bridgeport without the three-phase being turned on, which could damage the motor if it's only seeing those two phases. But quite frankly, it's a bit inconvenient to always have to walk around all of the junk that's next to the Bridgeport in order to hit that button. And I kind of figured I've got this extra space here above the switch for the Bridgeport motor that maybe I can take advantage of and have a remote start button for that contactor that's on the back. I've got a few of these Allen Bradley switches that were used on a different machine, and I think if I come up with a way to mount this up here, it'll be a whole heck of a lot more useful. So I designed up this enclosure in Fusion 360 and then printed it out on my 3D printer. Just another one of those cases where having a 3D printer in the shop, I think, is indispensable. So let me get this thing wired up and mounted in place. The first thing I need to do is put some heat set inserts into the back here so I can use some screws to put the back cover on. I've got this scrap piece of control cable. It's got more conductors than I need, but I think it'll work for this. I put a grommet on the back cover in order to protect the wire once it's installed. I'll get this wired into the control panel on the back of the bridge port and mounted above that power switch. Yeah, this might be a minor inconvenience thing to have to go push that button on the back of the controller, but I think with this thing now mounted on the top of this switch here with some double-sided tape, this is just going to make, shop life just that much a little bit better than it was the day before. And, that makes all the difference sometimes. Well, I made some progress here on the surface grinder, at least as far as coolant control. I was getting coolant flooded all over the front of it. It was going down the back, and it was just kind of creating a mess. So I just went up to Menards and bought some, this is like 90 thou, I think, acrylic, and I cut it down so it's easy to remove. And that takes care of all the junk that's either splashing off the back or the coolant or off the front. But what I also did is I 3D printed this little bracket on the back here. This mounts where I think traditionally you would have a custom made shield or whatever, but I made it a little bit oversized, so there's a little bit of a lip here, so any coolant that splashes on this will fall down into the tray of the table. And then I molded a slot in the top of it for a spark shield. I need to make some further modifications to this. This thing needs to be taller. I also want to go ahead and put some holes in the bottom, because right now this thing is full of coolant. And if I put some holes down here at the bottom of this slot, or at least one, it'll give a place for the coolant to drain out of it and then go back down into the tray. I do need to level this machine. I don't believe it's quite level because I find that this is the high end of the table. It eventually drains, but a lot of the coolant ends up on the other side. So I need to make this a little bit taller. I think I'm going to make it wider and then sort of bend some wings on it, and that'll help capture any sparks. I think it needs to be just a couple inches taller, and I'll be good. Well, some years ago, I had visited my friend Ron Grundy up in Milwaukee, as you might recall from some videos I've done in the past. I discovered Ron through Keith Rucker, who met him as Ron had worked for Kearney and Trecker for like 30 years. And I think that's how Keith originally found Ron. Well, Ron invited me to come up to his place to learn some hand scraping. Ron was a scraper hand for Kearney and Trecker for a good portion of his 30 years while he was there. And I learned some hand scraping and had a blast. And while I was up at Ron's, I had taken with me a straight edge that I had machined, and this is the result. I know many of you have seen this before, but this is the straight edge I scraped. I had the bottom of it mostly scraped in while I was at Ron's, and then finished the rest of it at home. And a viewer of the channel, Craig, had made this box for me to store the straight edge in, and this thing is fantastic. All right, so what's the point in me telling you all this? Well, if you watch my channel, I'm sure you watch Keith Rucker's channel, and Keith has been holding some hand scraping classes at his shop in Georgia every couple of months, and he's been sending some emails out about the class and been talking about hand scrapers. And one of the people he mentioned is this Hudson Manufacturing. This is a hand scraper made by I forget his name off the top of my head. Hudson Manufacturing. He has a website to purchase these, and I decided to get one. Now, this one that Ron gave me is fantastic. It works great. I even made some extra blades out of some tool steel. This one here is designed to take blades that you would use for a biax hand scraper. I also bought this scraper blade, which has a very nice small brazed on carbide blade on it. This fits in here, tightens down. I wanted something small like this to get into some tight spots, because when I start scraping in the especially the compound for the South Bend, I really think I'm going to need something small like this. So this will take blades like this, and I also have this kind of a blade which has a clamp on the end of it for accepting a traditional Sandvik piece of carbide. So I have some Sandvik carbide. These can be ground at different radii for different widths of your scrape. And so this will come in handy for when I do more hand scraping. And to that end, I am going to be at Keith Rucker's at the end of April, beginning of May, for his next hand scraping class. I haven't had an opportunity to sign up for his classes until now, mostly because it's winter up here in Ohio, and I really didn't want to take that drive down to southern Georgia in the middle of the winter. It's going to be like a 13-14 hour drive. I'll probably shoot it all down in one day the first day, but then on the way back I might take my time, take an extra day off of work. So I am very much looking forward to that. I do know that one of the viewers of my channel here, I'll get to meet them when we get to Keith's, because I believe he signed up for the same class. So yeah, Hudson Machinery. This thing is really well made. Nice bluing on it. So I'm looking forward to putting that to use down at Keith's. Now that I have the Dr. DRO set up on my horizontal milling machine, cutting spur gears and helical gears is a lot easier. This happens to be a gear from the 13-inch South Bend lathe that is yet to go back in it. Now, if I'm going to be making gears, or if I'm going to be working on these machines, it might be useful to know whether or not this gear tooth profile is at the correct dimension. I've seen a couple videos recently, including one from Mr. Pete, where Lyle shows how to use a special kind of a caliper to measure these gear teeth. And I've got a new tool in the shop. This is almost identical, might be identical to the one that Mr. Pete was using. This is a Brown and Sharp gear tooth vernier caliper, and it's used to measure the chordal addendum and the chordal thickness of a gear tooth. Yeah, it's a bit of a mouthful. I don't know exactly what that means. Can be found in the machinery's handbook. If we look at, there's some diagrams in here of exactly what that is, and it even shows how to use a vernier gear tooth caliper. But the chordal thickness is the thickness of the tooth at the pitch circle diameter, and the chordal addendum is the height between that pitch circle point and the top. Now, the reason why they call it a chordal thickness and a chordal addendum is because the top of the gear is also rounded. So it's not exactly the way that you would calculate the tooth depth and the addendum. There's a little bit of extra numbers that have to be derived. And there's a table here on this page of the machinery's handbook that helps you calculate what the chordal thickness and a chordal addendum for a full depth gear tooth would be. Now, this particular gear is a 48 tooth, 14 diametral pitch gear. So how would I figure that out? Well, if I go down here to 48 teeth, it's giving me this chordal thickness and cordonal addendum. Now this happens to be for a 1 diametral pitch gear. So in order to find out what those should be for a 14 DP, you divide that by 14, and that gives you your number. So for a 48 tooth gear, the cordonal thickness should be 0.1122 inches, and the cordonal addendum should be 0.0723 inches. Now you can use this table, you can look this stuff up and do the math, or I've actually built a little application here that will figure it out for me. So for a 48 tooth gear, 14 DP, 14.5 degree pressure angle, these are the basic dimensions of the gear. You can see the addendum is 0.0714 inches. The tooth thickness is 0.1122 inches. Now I'm also showing the total depth and cutter selection. This is for actually cutting the gear. But if I'm going to measure this with a vernier caliper, I need to figure out what the cordonal tooth thickness is and the cordonal addendum. So this calculates it for me. It just so happens that this gear tooth is so small that the thickness is identical, but the cordonal addendum is slightly different here. This is 72 thousandths and 3/10, and the calculated addendum is 71 thousandths and 4/10. Not a whole ton of difference, about a thousandth of a difference, but if you want accurate gears, you need to know this. Now, of course, at 48 teeth, there is not going to be a whole lot of variance between the two, but the larger the gear, right, fewer number of gear teeth, this is certainly going to get a little bit wider of a gap. So I have this Brown and Sharp gear tooth vernier, and it is in okay shape. It's a little bit, it's got some stains on it. It's a little challenging to read the vernier scale, but if I want to measure this gear, I need to set the vernier caliper to the correct dimension so I can see if it's worn, because not only do I want to know if I'm making a gear correctly, but I want to know, is this gear worn and do I need to remake it? So I am far from any good at reading vernier calipers, so I'm going to have to figure out just how to get this thing lined up with what I'm looking for. And I'm zoomed in here with my camera, and I'm actually using that to try to read this. And I don't do this every day, so this is not something that I'm super comfortable with doing. A little oil on here. This is very difficult to read because it is rather stained, a little bit of rust corroding on there. So instead of using this micrometer, I could use this one. This is another one that came into my possession. This one right here is made in Germany. There is no maker's mark on this one to know who made it. However, along with that one and the Brown and Sharp, I came across this one. This is a larger one, and it appears to be the same design as this one. This says made in Germany on it, but here you can see it says CSE made in Germany. So I'm suspecting that CSE might be the manufacturer of this larger one as well as the smaller one. Now this big one obviously is only good for large gears because the ends of these calipers are going to be a little bit too big to fit into smaller gear teeth, higher number of gears. But this vernier is actually a little bit easier for me to read. So even though I still will need to zoom in on it with my phone to read it, I might actually have a better chance of getting this set to the value that I need it at. So right there we are at, that's 75 thousandths, right? But I need 72 thousandths and 3/10. So how do I do that? Okay, that's going to be 50 thousandths. So I think that's 60 thousandths, right? Because the 3 is lined up with the 10. So I want the 23 to be lined up with a line somewhere. I believe that's how you would, that could be it there. Very difficult to read this. Zoom in on it even more. Next will be this one. This now needs to get set to 112 thousandths. So it looks like we're already on 100 thousandths. Reading this caliper is the hardest part because I don't really look at vernier calipers that often. It needs to be 112 thousandths. So I need the 12. So that should be about 112 thousandths there, because the 12 on the bottom scale lines up with the 4. So that should be 112 thousandths. Now to check this gear, I just need to set it on there. Let me zoom in here so you can see this. I'll set that on that gear tooth, and that looks really good. There's no play in this. So I'm going to think that this gear is actually in fairly good condition. So these 3 gear calipers, these are utilities for me, so I'm not too worried about collecting them. I might keep this one. I'm not sure if I'll keep the Brown and Sharp, but these 2 I think will come in more handy for me. Even though I don't have too many large gears for them, I'll be glad to have this. It'll be a little bit easier to make sure that they're good condition. And having this calculator is certainly going to be a lot easier than trying to flip through Machinery's Handbook every time I need to measure a gear. Well, part of the same auction lot that I scored those verniers, I came across this. This looks like it has like a CCR or something in the middle of it. I don't know if that's a manufacturer, but this looks like it's some sort of a go, no-go gauge or something like that for gear teeth. This dial on the right adjusts the thickness, and then of course we have a half thou indicator to measure the depth. I imagine this was probably being used for like quality control. I really don't have a use for this, so I'm not sure what I'm going to do with it, but it's kind of cool. Another new tool that I added to the shop collection is this Starrett 459 cutter clearance gauge. I've only seen one of these maybe once or twice before, but when I saw it in an auction lot, I'm like, okay, I think I need to have one. Eventually, I'm going to get my tool and cutter grinder set up, and when I do, something like this will come in handy in measuring the clearance angle of a milling cutter. So, for example, here's a nice big milling cutter that would be used on my horizontal milling machine. Here's another one, just a few more teeth. And the way this works, I actually sent an email to Starrett, and Starrett forwarded me some directions on how to use this, as well as this diagram here on using it a couple of different ways. So this foot here slides back and forth. Depending on the type of cutter you're measuring, you would swap this around. This would be hooked on one of the milling teeth. So the way that I understand this is used, we'll loosen up this gauge part here. I'm going to hook this little tooth here on one cutter and then rest the foot here on the right on another one, and then just going to slide this down with my finger here until I can eyeball that coming in contact with it and be flat across that cutter relief. So this looks like this is about 6 degrees of relief. So the advantage here will be when I start setting up my tool and cutter grinder, I'll be able to set the proper relief angle for a cutter like this. Maybe 7 degrees, 6 or 7 degrees. Let's see what this one is. This one right here looks a little bit more radical. So if I use the main, it's kind of hard to say what's the primary relief on this one or what's secondary relief. You know, the secondary, if I consider that steep angle secondary, that is about 17 degrees. That could be the primary relief angle. It's kind of hard to tell with this particular cutter, but I think it might be. So that's kind of cool. Like I said, I think I've only ever seen this one or maybe 2 other times in all the videos I've seen. I've come across these on eBay and stuff, but they're usually fairly high priced. This right here I got for a fairly decent deal, along with some other tools that I'm adding to the collection. So yeah, cool. A few other pieces of metrology gear that came into the shop from a viewer from one of the southern states. Had no use for these, so asked if I wanted them, and I said sure. So it's the ubiquitous Starrett last word dial indicator. I do like these. I've got a couple of them already. This one is in exceptionally good shape. I'm sure I'll find a use for that. This is a Fowler 0 to 1 micrometer. Although I'll be absolutely honest, I don't know what I would use these flat anvils for. I haven't checked it for calibration, but I don't know if you know the purpose of using these flat anvils. Is there a specific use case for these? I'd be curious to know. It's a little squeaky, might need some instrumentation oil. I do happen to have some Starrett instrumentation oil, so I can clean this up a little bit, put a little bit of oil in it. Also, this is a Fowler made in Japan. This is a ID micrometer. I think it goes up to 1 inch down to maybe 200 thousandths. Yeah, 200 thousandths to 1 inch. I have one similar to this. I don't know the manufacturer of that one, but yeah, nice little micrometer. It's missing whatever was supposed to be in there. I don't know if it's another one of these caps. If you know, let me know. Drop a comment down below. And then also is a set of radius gauges. I don't see a maker's mark on these, although they are stamped West Germany. So this is pre-unification, obviously. Not sure what German manufacturers there are, but it appears to be a complete set from 3/64 up to 1/2 inch. So yeah, I've got a few of these already. I think I've got maybe a Mitutoyo set, but this is a nice set. Thank you to the viewer that sent these in. They will definitely get some use. So I've had this large face mill here for a while, but what's new here is the NMTB 40 holder that it's mounted to. When I was machining one of my cast iron straight edges, I was using this cutter, but it was mounted to this holder, and I found that I needed more clearance from the spindle. And it is so hard to find, at least at a reasonable price, holders for something like this. I came across this one on eBay. It was less than 50 bucks. It gave me about another 1/2 of an inch, and I think that's about all I really need, because I hope to be machining some more straight edges here in the future. I have this 12-inch Rucker straight edge, as well as this 9-inch Rucker straight edge that I would like to machine and get ready for scraping. As I mentioned earlier in this video, I am going to be headed down to Keith's for his hand scraping class, and I figured if I have these machined and ready to go and take with me, if I finish off the 18-inch straight edge that he's providing as part of the class, then maybe I could start tackling these as well, time permitted. I'm not sure I'll even get through the 18-inch, but just in case, we've got this. That's going to be it for this week. Just a quick little odds and ends video, some updated mini shop projects. Done a lot of machining going on in the shop this week. It just needed to take a little bit of a break, but we'll be getting back to it here very, very soon. And as always, if you like the video, give it a thumbs up. Subscribe if you're not a subscriber. And if you'd like to support the channel in other ways, there's some links down in the description that'll let you know how to do that. Thanks for watching, and we'll see you on the next one.